Okay, today we will finish talking about this OCL thing, and it won't be too long. We will have more time for you to ask a question and figure out what is the point that is very hard to understand, and we solve the problem so that you can have a better understanding before you actually start preparing your finals. Okay. Speaking of the finals, we do have a final schedule there, but since we will make it online and open note, believe it or not, it doesn't make any difference to be open note or closed note because it's just like this. Okay, so it's gonna be open note, and I will give you I will make the the final test paper available to you within I will make it available throughout the end of next week, which is gonna be the around this 5-6. So what I mean is I will make it available like at least a week there, and then what you want to do is you pick a time. It doesn't have to be the time that for our it doesn't have to be the time which is scheduled for this class. Okay, the final time scheduled for this class. Yeah, there's a final schedule there, but since it's online, we don't have to stick to that. Okay, so it's gonna be open note, and we will have yeah, I happen to bring this here. We'll have this it's actually 8 page, so there's a lot of questions there, but some of them like indirect proof, direct proof, and those inferences. You can't have them solved pretty quickly. Actually, it won't be very hard like some of our exercises. So basically, I want to see if you can apply those knowledge, apply this proof to solve some problem. It doesn't have to be a very hard problem, and also you will have some Z, of course, Z and OCL predicate. So starting from the proof to Z, that's basically covered whatever we learned after the midterm. Okay, and also we will have some bonus there, so gonna be some extra credit there, but it won't be very easy, so please try to solve it. Okay, I will talk more about this in next class. So today let's continue to talk about this, finish talking about this OCL. That's a little bit overview, a review of this class diagram, okay, which contains some of the information, but not all the information we want to specify. This information includes the relationship, the structure of the whole system, but during the last 2 classes, we've been extending this. We've been keeping extending this class diagram with more information, such as we put new invariants, like we define that age should be greater or equal to 18, right? And also we initialize some of the value, right? We derived the value of some variable, and we extend the class with operations with new variables, with new operations, right? That's all we can do. We can do them all with OCL. Okay, and then let's see what else can we do. We are reaching this invariance. Okay, then that's how we're using the association classes. And another important thing is we use the dot. Remember how we use the dot? We use the dot to help us to navigate through some certain path, right? Like if we're in the transition and transaction dot card will return you the card that belongs to this transition. No, the card that this transition belongs to. Okay, something like that. And we can navigate more, like transition.card.owner.program. We can do that. So we can navigate through a certain path. And if you navigate through different paths, the result might be different. Remember that? Because it's just depends on the path. It might make difference there. Correct. And let's see, what do we want here? Define the query operation. We can define a query operation like extend a class with like this, get level name. So this actually doesn't exist. This method doesn't exist in the membership class. Here we're using OCL with this define keyword, def keywords, to extend the class with such a method. Okay, which the value of this method, it returns the current level .name. All right. So in the final, I'm not like expecting you know exactly every single detail of the OCL, but some of the basic thing, like what I mentioned again and again, such as this invariance, this thing. Try to not only memorize what is invariant, but also try to apply the invariance, use the invariance in the problem solving. Okay, in the final. Alright, let me see, what else do I want to do? Okay, let me mention this a little bit. So the enumerations with enumeration with OCL, so it's gonna be pretty similar to the enumeration in Z. Okay, suppose this, let me write it down. Context is in membership, and the invariant is implies okay. So this, I think you can tell what it means from this expression here. So right now we're in the context of membership, and the invariant here is current level dot name silver implies card color is silver. Let's see, we're in this membership here. Alright, look at that membership class, and current level's name. So see, current level is we navigate to through the current level, we navigate to the service level. So it makes sure that the service level's name match the color of the customer card. That will make sure the name is silver implies the card color is silver. And pay attention to this. So it actually help you to enumerate some of the values of the color, right? Because silver is one of the value of color. Okay, when we're using this format, that means silver is one of the color. Okay, that makes sense, because the color may include silver, gold, and maybe other color. But here we're using one of them. Okay, so if you are pretty familiar with programming language, this makes more sense. But there where you start, that's a difference. Okay, so that's enumeration. Well, this is easy. And let me see if there's something else I want to explain. Okay, so the collections, we know what are collections, right? We know what is a set, a sequence. Okay, for all those collections, so sequence has the order, set doesn't have the order, so here. But for all the collections, we have some operations that we can do. If you remember, like collections, arrow, with the arrow size, which tell you the size of that collection, right? Size, we can get the size of the collection. We can have the count with the object, the occurrence of the object, and we can test if that includes something or include or exclude, or is empty, not empty. Okay, so we can use these operations in our invariants to put restrictions on your system you're specifying, right? For example, if we want to, like in the loyalty program, we want to put a constraint there that if you are a program partner, you have to deliver at least one service. Got the question? If you are a program partner, you have to deliver at least one service. Okay, suppose now we're in the loyalty program, right? And if you are program partners, which we navigate to the program partner through the partners. Okay, and partners, and then we navigate to service. Partners dot self dot partners dot delivered services, which returns all the services provided by the partner, right? By a partner. Then we just need to make sure that the size greater or equal to 1. let's write it down so it makes more sense. Converges size greater or equal to 1. Okay. So that makes sure that loyalty program at least offered one service, okay, through its partners. But if you want to do something like okay, for this two, do you think there's any difference between these two? Any difference? I mean the meaning, the logic specified by these two different OCL statements. Partners. No, it's not missing partner because it's in the context of partner. See here. Okay, so contexts are different. One is loyalty program, one is partner. So if you look at here, one is in the here, one starts from here, loyalty program. One starts from here. The first one is loyalty program dot partners dot deliver service size greater or equal to 1. The second one is program partner dot deliver service size greater or equal to 1. So can you tell the difference here? But actually the logic is there. The logic is different. Okay.
The first one's saying that every partner that delivers must deliver at least one service. The second one is saying a specific partner must deliver at least one service.
Yeah, the second one is correct. The first one just said the loyalty program must deliver at least one service. Because this actually self.partner, it returns all the services delivered by all the partners in that loyalty program. So this actually makes sure the loyalty program, the loyalty program delivered at least one service. The second one says that specific partner delivered at least one service. Okay, clear? Is that clear? Make sense? All right. So that's the size. So we can use this collections operations to do the things we want. Yeah, and we can like if we come from here, we should have some more constraints like the number of member, the number of customer equals to the maybe the number of customer card, something like that. We can also use the size to specify that. All right. So I won't list everything there. Okay. And also we have this for or and is empty. Those things. Let me give you some example. Let me write it out, and you can tell me what does that mean. Okay. So we're in loyalty program. And the invariant is partners dot self dot partners dot delivered services for all. Membership dot account is empty. Okay, for this part, we're in the loyalty program. Now we're saying like partner dot deliver services for all points earned and points burned. They are equals to 0, which implies membership dot account is empty. Look at this. If you have that in your computer, look at this class diagram and try to translate this into a natural language. So first, let's still remember what is for all.
Upside down.
What's that? Yeah, for all actually means. So here we have a collection, right? We have a set. For all means for all the elements in that collection, they meet this condition. Okay. Partner delivers service. If you look at here, our partners deliver services, and we have points earned, points burned. Right? If everyone's points is 0, that means membership.account is empty. Okay, maybe a little bit hard. So
Can you repeat that?
what's that?
Can you repeat that?
Can I repeat?
Yeah, can you repeat that? The meaning?
Okay, so it's here. I haven't tell you the answer yet.
Oh.
Yeah. Okay, so but what is in your mind when you see this specification?
No, I mean I was trying to understand it from the natural language.
Yeah. So yeah, I'm trying to let you transfer that to natural language. Okay. So basically, let's see this part by part. So we have partner deliver services. So inside that loyalty program, okay, first we have a program, loyalty program. And that program has a lot of partners and deliver a whole bunch of services. Okay, deliver a whole bunch of services. This basically means for all the services delivered by this loyalty program, okay, all the services delivered by this loyalty program, they meet points earned is 0 and points burned is 0. Okay, that means for every service, like it's a discount or something like that. Basically, it's for all the services, it's like discount, because in a discount you just give the membership card and do not have any points earned or do not spend any points. So their points are all 0, right? Which implies the membership doesn't have a count at all. Okay. So if you still remember, so for some of the loyalty program, you have the services of earn the points, spend the points. You earn the points by flying with the company. You earn the points by spend money with a credit card, something like that. And then you spend the points by buying a ticket, purchase a ticket. Or there are some other services like discount. So you just present a membership card and that store will give you discount. Okay, so that means for this certain loyalty program, it doesn't offer any method to earn points or burn points. It just offer the service like discount or something like that. Okay, so if we are speaking that in natural language, that means when the loyalty program does not offer the possibility to earn or burn points, the members of that loyalty program do not have the account. Okay, so that means if you are not providing any service to earn or burn the points, I don't have to assign an account to you because that won't change. Every time it's 0. Okay, so that basically means that. Okay, and the important point here is for or. Okay, if you are using for or, that means you are making sure that all the elements in this collection meet this condition. Okay, for all the elements in the delivered services, they meet the condition that points earned equals to 0 and points burned equals to 0. Okay. All right. Next, let's look a little bit about the navigation. Okay, we've talked about navigation. So we navigate through from a context to different classes. Okay, now let's see more about navigation. All right. Okay. So we've mentioned the concept of set, right? So is there any duplicates? Do you still remember? Any duplicates element in the set? Is there any duplicates in the set?
There could be. Depends on the set. If it's an ordered set, there might be. If it's an unordered set.
No, if it's a set, the duplicates is not.
Oh, sorry,
there.
I'm thinking of a relation.
No, it's not relation. It's set.
Set.
Duplicates is not there. Okay. And now I want to introduce another concept. It's a bag, which may include the duplicate, so it's just a bag of something. Okay.
Wait, a bag?
A bag.
Okay.
Yeah. So it's some a concept here defined in OCL. All right. Now let's see if we want to state that number of customer of the class program partner. Let's look at this. Program partner, we have a number of customers, right? Okay. So if we want to state that the number of customer holds the number of customers who participate in one or more loyalty programs offered by this program partner, what should we do? What should we do? Let me repeat that. So we want to state that the number of customer here, the number of customers in the program partner, okay, in the program partner. So this attribute holds the number of customers who participate in one or more loyalty program offered by this program partner. So we want to say something like that. Let me give you one possible solution here so that it makes more sense when you see this specification. So we're in the context of program partner. Okay. And our invariant is the number of customers equals to programs dot participants size. Okay. So we want to say that this number of customers in the program partner class holds the information, which the information is all the members, the number of members that participate in one or more of the loyalty programs provided by this program partner. If you still remember, one loyalty program can have a lot of program partner, and one program partner may participate in many loyalty programs. Okay, so I'm saying here in the program partner number of customers. So like in Delta, it has not Delta, maybe a gas station. It has the loyalty program which help you get points. It has another loyalty program which just give you discount. Okay, so it has two loyalty programs for one gas station. All right, so here I want to specify this number of customers actually gives you the number of all the customers participant in all the programs offered by the gas station. Okay, that's what I want to speak here. So here what I use is this invariant. So number of customers equal to programs dot participant size. Okay. However, when we are using, so this is the thing I want you to remember. When we say programs dot participants, participants, let's see, yeah.
Your
So see,
customer?
the programs dot participants, we reach the customer, right? Okay, we're reaching the customer. So it basically it gives you all the all the programs offered by this partner and all the customer that belongs to all the programs belongs to this participant, belongs to this partner. Okay, so like I can offer, as a partner, I can offer maybe 3 or 4 different loyalty program, and I have a whole bunch of customer belongs to each of these programs. So number of customers reflect the total number of customers I have, no matter what kind of program they are in. All right, okay, but this actually may have the problem of duplicates. Okay, because as a customer, I can participate in different loyalty programs for one company. You think so? Right? I can participate in some mileage program of Delta. Also, I can participate in the discount program of Delta, or I can participate in the maybe some employee family loyalty program as well, right? So I can participate in different program offered by one company, right? That's why when we are in this program partner, after we navigate to the participants, so this actually returns you a set with whole bunch of duplicates. Okay, whole bunch of duplicates. So if I participate in 4 different programs, you can only count me once instead of 4 times. If we want to do that, we need first use this operation as set to make sure it is a set. Okay, this gives you a back. It doesn't remove the duplicates. Only when you do this as a set, it will help you remove the duplicates, and then you can count the size of that set. Okay, does it make sense? Yeah. So when you are navigating through this dot, what it returns. So what it returns is actually a back. It's similar to the set. The difference is just the duplicates. So if you want to make sure, I didn't mention that in the last several classes because we are not mentioning the duplicates. But if you want to make sure the duplicates are removed, you need to use the arrow as set to make sure that it returns the set, removes the duplicates. Okay, so write it down. The as set removes the duplicates. Okay. All right, and also precondition and post conditions. We've learned a whole bunch of that. Let's see here. Okay, let's give this example. Context customer. Birthday happens. Precondition can be none. And post condition. What is post condition? It's a customer. Okay, birthday happens. We define a new method to that. Okay. Customer, birthday happens. What happens on the birthday is we want to plus the age with 1, right? Because if you have an experience after you register in some website, after birthday it actually will ADR age with 1. Everything Facebook. So when you register for Facebook, maybe you're only like in high school or something. Then after your birthday happens, it will continually add your age with 1. Okay, so that's basically what we are trying to specify here. Birthday happens. Okay, so the post condition is age equals to age plus 1. Is that true? Is that correct? Okay, is that correct? Anything wrong with that?
Do you have to navigate?
No, because age is already in the customer, right? Age is in the customer, right? How about this? Shall we put age prime?
Oh.
Is this correct?
Yes.
Are you sure? Age prime is in the Z specification. Okay, don't get confused. We mentioned that if we want to use a the pre-value of the age, we use this at pre. I mentioned that once, I think last week. Maybe you forgot. So in the Z specification, yes, we are doing age prime. Yeah. Okay, age prime or something like age prime. But here we're doing the age at pre. Okay, don't confuse. Don't get confused. So this is a precondition, post-condition with the keywords pre and post. Okay, remember this? Okay, those keywords pre, post, invariant. Invariant, define, body, those things. Okay. All right. Also, we can apply this at pre not only to the value but also to function. All right, because a function has a value, return value. Okay, so that means the let's see, context service upgrade points earned. Okay, so we have a post condition for this operation, which means calculate points equals to calculate points at pre. Okay, so that means we can apply this at pre not only to an attribute but also to an operation. Okay, that makes sense. So that means when we are trying to make you, like, because you're in business class, maybe the calculated point for you, it was like the mileage is 1,000, but since you're business, I'll give you 2,000, so I'll give you plus 1,000 there. Okay. All right. Okay, the next thing I want to talk about is the inheritance, because we're in the UML. Okay, so UML include the inheritance, and so does the OCL. let's see, what is this? Program partner. The invariant is delivered services dot transactions dot points. So suppose it's 1,000, 10,000. Okay, suppose we're in the context of program partner. Here, program partner. Then we navigate to delivered services. Now here, the service is provided by the program partner. And then we navigate to transactions and points. So we navigate to transactions, okay, and the point of the transactions. We say the sum of all the points you earned should be less than some limit. So we don't want you to earn too much points. Maybe some program has that limitation. Okay. So okay, so this basically tells you that the sum of all the points should be less than 10,000. Okay, if we look at here, the transactions points here, the sum of all the points should be less than 10,000. But actually, the transaction has two subclasses. One is burning points, one is you can earning points. Okay, so if we want to put that restriction only on the burning points or only on the earning points, okay, what we should do is we need to put that constraint exactly to that subclass instead of transaction. Okay, suppose here we want to say you cannot earn more than 10,000. Okay, what can we do to modify this? Let me write it down. Still, we're using the sum. Okay, sum, something like sum blah. Okay, the sum should be still less than 10, but we cannot just use transactions dot points. There should be something here between the transaction and the points, because we want to put constraint on the earning points, not the earning and burning. Okay, if we're using transactions, that means the sum of earning and burning. But here we want to limit, to restrict the earning. So what we do is, here it's the same transactions, but we use the select method. Okay, is type of then dot points sum. Okay, so we just add one thing here. We use this select function to select only the type of earning from the transaction. Because transaction has two different subclass, two different type. If we want to select only the earning, we use this select method and specify the OCL is type of earning. Okay, OCL is a type of earning. Then we still use the dot points sum less than 10,000. That's how we restrict to a certain subclass instead of the general class. Okay. So that's inheritance. We can use it. We can use that. And the last thing I want to mention today is a keyword called let, which is just easy. So right now we're in the customer card. The invariant is let correct the data Okay, so we have this data, and then okay, so look at here, this part. Okay, we have a context which is a customer card. We're in the context of custom card. So let's look at here, custom card. We have a valid, a boolean called valid, right? And here we define a correct data, which is also a boolean. Alright, and let, you can just easily tell it from here. Let, just we assume like this, we define here. So this correct data, which is a boolean, it equals to first the validate from date is before today, and good through date is after today. Then we give this corrected date as valid, as true. Okay, so let in, which means for this condition, for this whole predicate, this valid inside within this group, but out of that group we don't care about it. Okay, so here So if valid, then we put the correct data as the false, and else correct data is true. Okay, so correct date, sorry, not data. So this state that either the valid from or the good through date of a customer card needs to be adjusted when the card is invalidated. Okay, so we define an extra variable here called correct data with this let. Okay, and we have some initial value here. But here in this specification, we actually so this we have initial value for this correct date. However, within this group, we still need to change that correct date with the valid. Okay, with the valid. So that means we change the valid to this correct date. Actually, this actually override the value of the correct date. Okay, so correct date has some initial value here, but then it's override. It's override here. Okay, but I mean here I want to show we have a let, which just let you create maybe something like a temporary variable. All right, temporary variable. So we have when we are writing some program within a method, we have some local variable. So this actually works that way. So we have some local variable instead of global thing, because you say the valid something, they are and good through, valid from, good through, those are all global things that you can access in the class. But here we can use some local variable to do something we want. All right, then we just use this let. Okay, so that's basically everything I'd like to talk about this OCL. Something may be a little bit confusing, but you just need to read these examples, compare that with the class diagram. So the main thing is we use OCL to extend. Now for this example, we use OCL to extend the information of the UML model. Specifically here, we extend that class diagram. We extend this class diagram. Okay. Extend this class diagram. So that's and a lot of details we introduced. Maybe some of the detail maybe still a little bit confusing, but all of them are tools that help us to extend the information, like the pre-post conditions, invariant, and this let. Okay, maybe this is more advanced, but I just want to mention that you can even define a local variable in this OCL. Okay, maybe this will not occur in the exam, in the final, but just let you know we can define variable there. So OCL is pretty useful. Okay, one thing pretty important is we learn the objectives, or we learn the Z specification and the OCL. So do not confuse those two things. Okay, so anyone a little bit confusing about those two? So let me ask you, what is the difference? What is the main difference you notice between this specification and this OCL?
The Z specification?
Yeah.
Well, Z, you don't have a context. You don't really, you
Well,
have predicates, but in pre and post conditions, but you don't have navigation really. Because you have to.
Oh, you don't have navigation, yes.
Yeah.
Okay, for Z, it's not that you don't have navigation. You can still do something similar to navigation, but they are in different level actually. When we're using OCL, we extend something already exists, right? We extend something already exists. We extend the class diagram. But when we're using Z, we can start from scratch, right? You see, you just submit the Z assignment. I just give you some natural language, right? I give you some natural language, and then I give you, I ask you to specify the system with Z, and then you use the schemas to specify the system. What are the variables? What are the conditions for the variables? And you specify an operation. What are the input, output, and the precondition, post-condition? Okay, maybe one thing confusing is they both have precondition and post-condition when they are trying to define some operation. Okay, so but in Z, it is we define that operation from scratch. But in OCL, we are extend the existing class diagram, or there's the existing operation, we extend the information for that operation. Okay, so they are basically in different level. So for Z, we design with Z we design a system. We specify our design of the system. With OCL, we extend the existing design. Okay, so with Z, usually I will give you a natural language description to ask you to specify that description. With OCL, I will give you, of course, I can give you natural language description, but I will always give you a class. Most of the time, I will give you another class diagram, so that you can use OCL to extend that class diagram. Okay, so they are in different level, but they have a lot of things in common. Like when you specify the conditions, you can use predicate, those similar predicate thing, this set. But here we have this method. We have a defined. So OCL are more towards the programming side, and Z is still towards the mathematics side. Okay, so they work on different level, and they have something similar, but two different things. Okay.
How often is this used in the real world?
What's that?
How often is this used in the real world?
In the real world? Yeah. So when you are trying, most of the time, if you're in the agile model, which is pretty popular, which requires you to do everything quickly, of course you won't see this happen at all. But there are some carefully designed systems, especially the systems that are security sensitive, maybe an airplane, Boeing, okay, airplane. So those things, you want to make sure every detail is very clear. You cannot accept any failure on that. So that should be the time you're using this kind of a specification, because you want make everything that you want assure everything is specified as the way we design. Okay, but in Agile we can afford the failure, right? We can just modify the system. But in some system, it doesn't do that way, and it's similar to the formal. Just when I say the formal specification in general, actually Z and OCL, they all belongs to that. When I say the formal specification in general, it's also different from the areas. Like in Europe and in US, it's different. In Europe, it's more maybe in Germany. Okay, so just the way people. The style people are doing the design, they are different. Okay. Okay. So at some place we want things fast. At some place we want things that is reliable. Okay. so it's different priority. But this is actually a good training to your logic and to make sure that we remove all the ambiguous, all those things. Okay, so all right, so that's basically finished all the things I want to mention in this semester. Okay, so you're done for this semester. What?
What are we going on Wednesday?
Wednesday we will talk a little bit about the final. Yeah. So that you will have a direction to make preparation. Alright, so any questions you want to ask? Okay, it's fine. If you have a question, you can to come to my office. Alright, thank you.